Hello students, I am Professor NAVNEET KAUR, Associate Professor in EC Department, Sagar Institute of Research and Technology, College Bhopal. Today I will be taking lecture on subject digital communication. The topic of the lecture is pulse code modulation. Pulse code modulation is a method of converting an analog signal into a digital signal. The pulse modulation schemes, which we have previously studied, like pulse amplitude modulation, in those the amplitude of analog signal can take any value over a continuous range. That is, it can take on an infinite value. So the techniques are analog pulse modulation schemes, whereas pulse code modulation is a digital pulse modulation technique where digital signal amplitude can take on finite values. In this case, the analog signal can be converted into digital by sampling and quantizing. This method is used to digitally represent sampled analog signals. It is the standard form of digital audio in computers, compact discs, digital telephony, and other digital audio applications. The basic operations which are performed in the PCM transmitter are sampling, quantizing, and encoding. The amplitude of the analog signal is first sampled regularly at uniform intervals, and each sample is quantized to the nearest value. A message signal is then represented by a sequence of coded pulses, which is accomplished by representing the signal in discrete time in both time and amplitude. As I told, the first step which we perform in pulse code modulation is sampling. Here the incoming message signal is sampled with a train of narrow rectangular pulses. To ensure perfect reconstruction of the message signal at the receiver, the sampling rate must be greater than twice the highest frequency component of the message signal. The sampled version of the message signal is then quantized and thus provides a new representation of the signal that is discrete in both time and amplitude. To exploit the advantages of sampling and quantizing for the purpose of making the transmitted signal more robust to noise, interference, and other channel impairments, encoding process is used to translate the discrete set of sample values to binary form, that is in the form of 1 or 0, which will be represented by pulses. Here we can see the process of quantization. Now, say we have a message signal which is shown by a sinusoid. This message signal is first sampled at regular intervals, where the interval between each sample is sampling interval Ts, which is defined according to the sampling theorem. Now, here we will divide the signal amplitude into quantization levels, which is always 2 raised to power n. Now, in between each quantization step, we will define a quantization level M0, M1, M2, and so on. Now, here each sample will be quantized to the nearest quantization level. Say, if I take the sample, which will be here. Now, in this case, since it is closer to the quantization level M0 as compared to any other quantization level, so this sample will be represented by this quantization level, which is M0. Similarly, any sample which will be in the range of LO1 to L12, it will be represented by quantization level M1, and so on. So here a sample value is approximated by the midpoint of the interval in which it lies. So the quantized samples, after they are approximated, they will be coded and transmitted as binary pulses. So we can say quantization is the process of mapping a large set of input values to a smaller set. The quantization is done by discretizing the signal with a limited number of quantization levels. The difference between the input value and its quantized value is referred to as quantization error. A device or any function that performs quantization is called a quantizer. Now, in this figure, we can see the transmitter of the pulse code modulation system as well as receiver of the PCM system. Now, here we have a continuous time message signal, which is first given to a sampler. The sampler will find the samples of this signal at regular interval. Say the first sampler is having an amplitude of 4.7 volt, second sample is having 2.1 volt, and third is having 2.9 volt. Since these samples are in the continuous amplitude range, so sampler we can say is an analog pulse modulation system. Now, this signal which is composed of the samples will be given to the quantizer. Quantizer will approximate each sample to the nearest quantization level. So 4.7 will be quantized to 5, 2.1 will be approximated to 2, and say 2.9 will be approximated to 3. Now, this quantized signal will be given to encoder. Encoder will represent each quantized sample in the form of binary signal 1, 0 and will be represented by the pulses, where 1 will be represented by high pulse and 0 will be represented by 0 level. Now, this signal will be transmitted over a channel and it will be received by a PCM receiver. Now, when this encoded signal is received by the receiver, there will be some distortion in the signal due to the properties of the channel. So, this signal will be given to the quantizer. We will regenerate the fresh pulses, 1 which will be represented by high pulse and 0 with the 0 level. Now it will given to the decoder. Decoder will decode for each combination of bits the quantized level, say 5, 2 and 3. Now it will be given to the holding circuit. Holding circuit will demodulate the signal and will generate a signal which will be the closer to the message signal. Now, when this signal will be given to the low pass filter, a continuous analog signal will be generated which will closely resemble the original message signal. Now, in this way, the message signal which was transmitted on the transmitter side will be received by the destination. Now here we can see the process. Now here, say we have first sample. Now since this sample is nearest to the quantization level 100, so this sample will be represented by the bits 100, where 1 will be represented by high pulse and 0 can be represented by either 0 pulse or negative pulse. Similarly, second sample is approximated to quantization level 7, which is represented by encoded output 111. So this second sample will be represented by 3 high pulses 111. And in this way, all these samples will be quantized and will be encoded into binary bits. Now, this is the complete block diagram which will summarize the whole PCM system. Now, originally, we have continuous time, continuous amplitude input signal, which is given to sampler. Sampler will generate discrete time continuous amplitude signal, which will be in the form of a PAM pulses, where PAM is pulse amplitude modulated signal. Now, this will be given to quantizer. Quantizer will generate discrete time, discrete amplitude signal, which are called PCM pulses. And this will be given to the encoder, where encoder will give digital bit stream, which is our output signal, which is represented in the form of pulses. So signal is digitally encoded for transmission. Applications of pulse code modulation. It is used in many applications like telephone system, digital audio recording, CD laser disc, voicemail, digital video, etc. They are primary building block for advanced communication systems. Now, this is all for today's lecture. Thank you.